All right, so everybody, I'm going to find the volume of a solid about the y-axis with y equals square root of x equals 1, y equals 0. We can do both methods here, and we will, all right? Both methods here will work. The first thing we really need every single time, and the reason in pre-calc you spent so much darn time graphing, is we have to picture what's going on. There's the square root of x, there's y equals 0, and there's x equals 1. And we like this because the inner point over here is 1 and 0, right? And our intersection here is 1 and 0. So our region here in green, right, is right there. Does everybody see it pinned between the three curves? And we're going to spin that region about the y-axis. Okay? Two ways to do this. There is the way where we say, hey, we can cut with a butter knife, right, across perpendicular to the y-axis and say, hey, volume's equal to the integral on the y-axis of 0 to 1 of the area, cross-sectional area, AY, dy. That is one method, okay? And that's the method we've done much more practice on. So, if I do that method, all right, does everybody see, as usual, that this is a washer, right? An inside radius and a outside radius. All right? Let's make sure we're recording. So we have an RO and an RI. So we'll use Callista's shortcut here. And we'll say, hey, I know that a washer has an outside radius squared minus an inside radius squared. I have to define those. Well, this time, looking at my picture, I think it sure is easy to see what the outside radius is, right? It is always 1, right? It is always 1. So the outside radius is 1. 1 squared is 1. We'll come back to that in a second. The inside radius, right, is some distance x, all right? But it goes to the curve y equals square root of x. Or if I solve for x, do you guys agree it's x equals y squared? Square both sides? All right. That distance x, then, is the inside radius. But what is x? X is y squared. So we get y squared squared, right? The inside radius is x distance, but that's equal to y squared. All right. So if I do this now, dy, I can write this out. I'll tell you this integral is 0 to 1, 1 minus y to the 4th dy. Tell you what, I'd like to use my calculator. Well, no, you know what? This one's easy enough. Maybe we won't. The integral of 1 is y. The integral of y to the 4th is y to the 5th. You guys agree? From 1 to 0. So pi times 1 minus 1/5 minus 0 minus 0. And I get 4/5 pi is the answer for the volume. And we just found the volume about the y-axis using our old method, right? Everybody agree this is our old method? Boom, done. Now, this is the harder way of doing it. All right, this is harder because we had to solve for x equals y squared up there. The other way to do this problem is to do it by cylindrical shells. All right? And every time, so long as the cross-section is going to be circular, it has to be circular for this to work, okay? We can use cylindrical shells. And cylindrical shells has a new formula for us. And I'm saving this because I want to use the 4/5 here. We should get 4/5 pi unless I made a math mistake. All right? Which is possible. I've been on a horrible roll today. All right? Everybody, we also know that volume equals going on the x-axis, 0 to 1, okay? 2 pi x, right, which is the circumference when we unroll one of the cylindrical shells, times the height, which is f of x dx. So looking at and realizing that we are taking a cylindrical shell, right, about the y-axis that is dx thick, all right, we end up then with this integral, which truthfully solves way faster, because what is the height? The height is y, which is equivalent to square root of x, right? dx, that's this red line height. I can pull the 2 pi out, and I can use my algebra 2 rules and say, hey, this is x to the 3 halves, right? I can pull 2 pi and I can do the antiderivative. Antiderivative of 3 halves is 5 halves over 5 halves. From what? From 0 to 1. Here we go. I'll flip it up. I get 2 pi times 2 fifths times 1 to the 5 halves minus 0 to the 5 halves when I do the evaluation. Everybody, last time I checked, 1 to the 5 halves is 1. 0 to the 5 halves is 0. 1 minus 0 is 1. What's 2 fifths times 2 pi? 4 fifths pi. Everybody. Kind of a pain in the butt, right? But I think this is much easier, all right, much easier in the long run with a little bit of practice than doing the butter knife cut over here, all right? But they both end up at the same spot. And they have to, right? Because we agreed we were finding the volume going about the y-axis. It had to be the same. Cylindrical shells, the method over here on the left, the red method, only works when you're rotating, all right? And you're getting cross-sectional areas that can be represented by a right circular cylinder. This will not work if they say the cross-sectional areas are squares, the cross-sectional area are triangles. This only works when you can have a right circular cylinder. All right, everybody, we will pick up from there tomorrow. AP problems, we're going to pick up and start nailing them out so you guys can see how they go. Keep practicing. We only got about a month left.